Hello. Now we are going to look at Venn diagrams. And a Venn diagram is a way of visualizing our sets, of drawing a picture of our groups so that we can understand them better because we can see them better. A Venn diagram looks like this. So we have our sets. So it's the set A that we're going to find the elements of in a minute is drawn as a circle, and then the set B, which we actually have the elements of, is another circle, and we can see there's an overlap between those circles, and there often is an overlap between our groups, and this is one of the things Venn diagrams can help us to understand, the relationship between different groups, between different sets. To begin with, we're going to find the elements of the set A. So I know I'm dealing with the elements of a set because I have my capital letter for the name of the set, and I have my curly brackets, and I have the elements of the set are called X, and the definition of X is the letters in the word follow. So I'm going to write down A is equal to, open up a curly bracket, and I'm going to have F, comma, O, comma, L, and then I don't repeat any letters, so I don't have another L, and I don't have another O, and I have W. So those would be the elements of the set A using lowercase letters, commas in between, curly brackets around them, and I'm not repeating any letters. And then B is the letters in the word gown, as in a dress. So if we look at the elements in A and B, when we're filling in a Venn diagram, we're always going to try and fill in the stuff that is common to both groups first, the stuff that would be in this overlap here. The name for this overlap is going to be the intersection. So where our sets overlap each other, we'll call the intersection, and we're going to try and fill in that part first. So what elements do we have that would be in both the red circle and the blue circle, both in the group A and in the group B? Well, F isn't in B, O is. So O is a member of both groups. So it would sit in the intersection. So the letter O would be inside the group A and inside the group B. And we put a little dot next to it to tell us that we're talking about an element. L is not in both groups. W is in both groups. So W would go in the space in between where it's both in A and in the circle B. And now we fill in the rest of the Venn diagram. We fill in the stuff that's only in A. So we have F and L. We put a dot next to them. And then we have G and N are only in set B. So that's how we can use a Venn diagram to look at the relationship between the sets. Before, particularly if we had longer lists of letters, it would be hard to see what was common to both groups. But by drawing our picture here, we can see the relationship between the two groups much more easily because we can see what is in the overlap, the intersection of the red and the blue group. So this Venn diagram, these circles that we draw to give describe the groups that we are talking about in sets, they can help us to interpret the relationship. Now, another idea that we can come across when we're dealing with Venn diagrams and sets is if we have equal sets. And an equal set just means that it has exactly the same elements. So if we look at the set C, it has the elements T, O, and P. They would be the letters that form the word top. And then the set D is P-O-T. It's the letters that would form the word pot. Now they're equal because those letters are identical. The order of the letters does not matter. So the fact that we have T and O and P in both of those sets means that if they are equal to each other because they have exactly the same elements. Now another concept that we can deal with, which is quite important for Venn diagrams and sets in general, is a subset. So subsets are groups within our bigger group, are groups within groups in general. So if we have the set or the group E. This time our elements are numbers, so we have 2, 4, and 6. And then the set F has elements 6 and 4. Now we can immediately see that the elements in F are contained in E. So F is a group within the group E, because we could say that it is just a part of the elements in E. So F is a subset of E, and the symbol for that is a really, really stretched out, horizontally stretched out C. So this long C shape, it is not the same, it's not drawn the same as just the letter C. It's a very elongated out C. That is the symbol for subset. So F is a subset of E. If we looked at that as a Venn diagram, we would have, I've drawn E in red or in orange here, and then F would be in blue. A subset should be inside the other set. It's a group within a group. So if we drew that as a Venn diagram, F is going to be in blue. We can see the elements of F are 6 and 4. So we have 6 and 4 here. So the set F would be fully inside the set E. It's a group within a group. Again, the Venn diagram helps us to see that. We can see that in the list, but it is very intuitive. We have a much better feel for the idea that F is within the group E when we draw our Venn diagram. And that's what Venn diagrams help us with. Now, we can break up the group E into lots of subgroups. So how would we write down all of the subsets of E? Well, we could start off and say we could just have the element 2 as a set. We could have the element 4. We could have the element 6. And they're all subsets of E because they're all made up of the stuff in E. We've already seen that 6 and 4 is a subset of E. So we could have 4, 6 would be one of the elements, it would be one of the subsets of E, or we could have 4, 2, or we could have 2, 6. And because the order doesn't matter, we wouldn't bother repeating, say, 6, 2 or 2, 4, because we've already covered them when we've done those sets. Now, those are all of the proper subsets. They're proper subsets because they are parts of the group E. But there are 2 other really important subsets of E, which are called improper subsets, and that is the set itself. Let me redraw that curly bracket. The set itself is a subset of E, and the most important one is that the null set is always a subset of every single set. So these are called improper subsets, and they're always going to be the same. It's the set itself and the null set, the empty set, and then the parts of E are the other subsets of E, the subgroups that would be obvious within E. So those are all of the subsets of E. Continuing, we have the set G. So the set G is all of the stuff in the orange circle or the red circle here, and the stuff in H, or the set H, is all of the elements that are in the blue circle H. So if it's in the blue circle, it's in H. If it's in the red circle, it's in G. So how could we list the elements of G? Well, we'd open up our curly bracket. We'd have 3, 6, and 9 would be the elements of G. And again, it doesn't matter whether it's in the blue circle. If we're inside the red circle, we are inside of G. It's an element of G. And then H, we have, open up our curly bracket, and we have 5, 6, 7, and 8. I'm doing them in numerical order in both cases. That's just for convenience of my own reading. We know order doesn't matter for our elements. So if I'd said 8, 5, 6, 7, that would be perfectly fine as well. Now, what are the elements that are in G and in H? Now, we looked at this before. That would mean that they met both criteria. They'd be in the group G and in the group H. So we can see this visually really easily, that 6 is the element that is in both groups. So we open up a curly bracket and we would say the answer to that is the set 6. So this idea where we're looking for what is in both groups, what meets both descriptions, or what is in both of our circles, that is called the intersection. And an intersection is a name that we might hear sometimes in American English for a large crossroads. So where roads cross over each other is an intersection. And it means the same thing here, where our sets cross over each other, where our Venn diagram circles cross over each other, that is the intersection. And the word we associate with that is and. So we need it to be in both G and in H for this to be true. If we wanted the elements that were in G or in H, we'd be happy with any of them. So if we were picking out letters and we were happy with anything in G or H, we would say we wanted the union of G and H. So that would be 3, 9, 6, 5, 7, and 8. Any of them we'd be happy with. So if we were happy with the stuff in either set, if we were picking it, then we'd say we wanted the union. A union is everybody working together, everybody coming together, and that's what we're talking about here. If we were looking for the union, we'd be happy with anything from the sets at all. Now, the number of elements in a set is called its cardinal number, and you use the hashtag symbol for it. So hashtag G means cardinal number of G, and it means how many elements are in it. So if we go to our red circle here, we have 1, 2, 3 elements in G. And how many elements do we have in H? What's the cardinality or the cardinal number of H? We have 1, 2, 3, 4. So we have 4 elements in H. Now, this is a symbol we have seen before. This symbol here, which is a C with a line through it, means element. So it's the set language way of saying element. Is for an element of H, is for a member of the group H, where we can go to our list or we can go to the circle and we can see no, it is not. So we could just say no. We can also write down for is not an element of H. Putting a line through our symbol says no, it's not. Is 8, 5 a subset? Our long C means subset of H. So is 8 and 5, 8 and 5, they are both within H, so they would form a subgroup, a group within the group H. So we would say yes, that would be true. We would be able to say 8 is a subset of H. Now, what would be the cardinality, what would be the cardinal number of A intersection B? So the symbol we have for intersection is an upside down U-shaped symbol, and A intersection B. Well, we know that that means the stuff that's in A and in B. So that means they have to meet both criteria. We have to be in both the red circle and the blue circle, and A and B are all the way over here on the left of the screen. So we have 1, 2 elements in that, so that would be 2. And what would be the cardinality, the number of elements in A union B? Well, a union is everybody together, so that's anything in A or B or both. So 1, 2, 3, 4, 5, 6. We would have 6 elements in A union B. And that's how we can use Venn diagrams to help us understand the sets, the groups that we are dealing with better. And that is what we need for now.